A+ലേക്കുള്ള വഴി ഇനി തനിയെ തുറക്കാം. Subscribe to the ENCLAPS channel. Ring the bell button and open success. It's that easy.
Hello. We studied about the industrial production of iron. And now you know about the different stages in the industrial production of iron. And today we are going to study about the different types of alloy steels. Alloy steels are prepared by adding other metals to steel. Alloy steels have properties different from those of steel. So now we are going to discuss a table which include the name, composition, properties and uses of different types of alloy steels. The first example is stainless steel. The different constituent elements present in them are iron, chromium, nickel and carbon. They are generally hard and hence used for the manufacture of utensils and parts of vehicles. Next example is alnico. Here the constituent elements are iron, aluminium, nickel and cobalt. They have magnetic nature, so they can be used for the manufacture of permanent magnets. Next example is nichrome. The constituent elements are iron, nickel, chromium and carbon. They have high resistance and hence they can be used for making heating coils. So now our table is complete and now I am going to ask you some questions related to this table. Okay. Now the first question is, which alloy is used for the production of heating coils? Explain the reason. When we discussed the previous table, we said that nichrome is used for making heating coils and it is mainly due to the high resistance of nichrome. Okay. Now the second question is, even though nichrome and stainless steel contain the same components, they possess different properties. Find out the reason. When we discussed the previous table, we see that both the nichrome and stainless steel contain the same compounds, that is iron, chromium, nickel and carbon. But when we discuss about their properties, we see that their properties are different. That is, stainless steel is used to make utensils while nichrome is used to make heating coils. So why they show different properties even though the constituents are same? It is because even though the constituents are same, the ratio of different constituents are different in both these alloys. So their properties also change. Now just look at the next question. Which alloy steel is used for making permanent magnets? Since alnico has magnetic nature, it is used for making permanent magnet. So now, do you got a clear idea about the alloy steels? Okay. Different types of alloys are prepared by changing the constituent elements and also by varying their proportion. Now we are moving to an important section, that is extraction of aluminium. In our day-to-day life, we use aluminium for different purposes. It is used for the transmission of electricity, for making cooking utensils, part of vehicles, reflectors and so on. If so, on the basis of the uses of aluminium, we can find out the characteristics of this metal. Okay? So look at the table. The first use of aluminium is transmission of electricity and it is used due to the electrical conductivity of aluminium. Next use of aluminium is, it is used for making kitchen utensils and it is due to the thermal conductivity of aluminium. The third use of aluminium is, it is used as reflectors and it is due to the metallic luster of aluminium. In the olden days, the cost of the extraction of aluminium is very high and hence it is costlier than gold. But after many years, two scientists named Charles Martin Hall and Paul Herold introduced a method called Hall-Herold process, which is a cost-effective method by which aluminium can easily extracted. So this metal later becomes a common man's metal. Okay. So bauxite is the main ore of aluminium and it is through the Hall-Herold process the aluminium is extracted from bauxite. This industrial production of aluminium involves two stages and they are concentration of the bauxite and electrolysis of concentrated alumina. So we can discuss each of these stages in detail. The first stage is the concentration of bauxite. In order to understand this in detail, we can consider a flow chart. Look at the different stages. At the first step, it is concentrated through leaching process. Then the impure bauxite is added to hot concentrated NaOH solution where it gets converted to sodium aluminate. Impurities are then filtered off. A small quantity of freshly prepared aluminium hydroxide precipitate is added and diluted with water to get more amount of AlOH thrice precipitate. The precipitate is separated, washed and then heated strongly to get alumina. Here the chemical equation for the reaction taking place when aluminium hydroxide is heated is 2AlOH thrice gives Al2O3 plus 3H2O. So the first stage of the aluminium extraction, that is the concentration of bauxite, is completed. Now aluminium has to be separated from this alumina. For that, a reducing agent should be added with this alumina. In the case of the extraction of iron, we used carbon monoxide as the reducing agent. So can we use the same carbon monoxide here? Absolutely not, because aluminium is an element which having higher reactivity. So we can't able to use the reducing agents like carbon monoxide here. Okay? But instead we need to use some strong reducing agent like electricity. If so, now we are going to explain how the extraction of aluminium is made possible with the help of electricity. For that, first we need a steel tank. Around the whole tank, a carbon lining is given. And here, thin carbon lining acts as the cathode. That means it has to be connected with the negative terminal of the battery. Here the carbon rods are selected as the anode and it should be connected to the positive terminal of the battery. Here alumina is taken as the electrolyte. Along with this alumina, melted cryolite, that is Na3Al(F6) should also be added, and that the electrolysis takes place. So what may be the reason why the cryolite is also added along with this alumina? It is because here the melting point of aluminium is much higher. So in order to reduce this higher melting point and to improve the electrical conductivity, this cryolite is also added here. Okay. So now just look at what are the chemical changes that happen when electricity is began to pass. Al2O3 gives 2Al3 plus 3O2 minus. Al3 plus 3 electron gives Al and 2O2 minus gives O2 plus 4 electron. Here when this process takes place, the carbon rods are removed in between. And what may be the reason for this? It is because during this reaction, the oxygen removed from the anode react with the carbon rod and as a result carbon dioxide is produced. So the carbon rod will begin to destroy. And because of this reason why carbon dioxide is produced continuously, the carbon rods are replaced in between. Okay? That is C plus O2 gives a CO2. So now, do you got a clear understanding about what is actually happened in different stages of the extraction of aluminium? So now, we can complete a table based on this. Here, the anode is carbon rod and cathode is carbon lining. The electrolyte used here is alumina plus melted cryolite. And the equation of the chemical reaction at anode is 2O2 minus gives O2 plus 4 electron. And the equation of the chemical reaction at cathode is Al3 plus 3 electron gives Al. So in this unit, we discuss about different stages involved in the manufacture of a metal and then the industrial production of aluminium and iron. See you later.
3 ലക്ഷത്തിലേറെ വരുന്ന ചോദ്യോത്തരങ്ങൾ ഏറ്റവും കുറഞ്ഞ ചിലവിൽ സ്വന്തമാക്കുവാൻ ഉടൻ തന്നെ ഡൗൺലോഡ് ചെയ്യൂ ENCLAPS the Learning App.